Calculating conduit fill for Category 5 communication cable involves several steps. Firstly, determine the outer diameter of the cable. Refer to the cable manufacturer's specifications for the outside diameter of the Category 5 cable being used. Secondly, calculate the cross-sectional area of the cable. Use the formula cross-sectional area equals pi times outer diameter squared divided by 4. Where cross-sectional area is the cross-sectional area in square inches, pi is the mathematical constant 3.14159, and outer diameter is the outer diameter in inches. Thirdly, determine the conduit diameter. Select a conduit with an inner diameter that is at least 1.25 times the outer diameter of the cable. Fourthly, calculate the conduit area. Use the formula conduit area equals pi times inner diameter squared divided by 4. Where conduit area is the conduit area in square inches, pi is the mathematical constant 3.14159, and inner diameter is the inner diameter of the conduit in inches. Fifthly, calculate the fill percentage. Use the formula fill percentage equals cross-sectional area times number of cables divided by conduit area times 100%. Where cross-sectional area is the cross-sectional area of the cable in square inches, number of cables is the number of Category 5 cables being run, and conduit area is the conduit area in square inches. Here's an example. Cable outer diameter is 0.25 inches. Conduit inner diameter is 1.25 inches. Now, let's perform the calculations. Cross-sectional area equals pi times 0.25 squared divided by 4, which equals 0.491 square inches. Conduit area equals pi times 1.25 squared divided by 4, which equals 1.2272 square inches. Fill percentage equals 0.491 times 1 divided by 1.2272 times 100%, which equals 4.1%. Conduit fill should not exceed 40% to allow for proper bending and heat dissipation. The fill percentage calculated should be less than 40% to ensure compliance with code requirements. The National Electrical Code, or NEC, provides guidelines for conduit fill to ensure safe and efficient electrical installations. These guidelines are essential to prevent overheating, insulation damage, and potential electrical hazards. The NEC specifies the maximum allowable percentage of conduit fill based on the number and type of conductors or cables within the conduit. For communication cables like Category 5, the fill percentage is generally limited to 40%. This limitation accounts for the need for adequate space for heat dissipation and ease of pulling cables through the conduit. Understanding the NEC requirements is crucial for electrical engineers, contractors, and installers to ensure compliance and safety. Consulting the specific NEC tables and articles related to conduit fill is highly recommended for accurate and up-to-date information. Factors influencing conduit fill calculations. Firstly, cable diameter. The outer diameter of the cable is a fundamental parameter in conduit fill calculations. Cable manufacturers typically provide this information in their product specifications. Accurate measurement or specification of the cable diameter is essential for precise calculations. Secondly, conduit size. The size of the conduit, specifically its inner diameter, directly affects the available space for cables. Conduit sizes are standardized, and their inner diameters are readily available from conduit manufacturers. Selecting the appropriate conduit size is critical to meet fill requirements and ensure ease of installation. Thirdly, number of cables. The number of cables to be installed in a conduit directly impacts the fill percentage. As the number of cables increases, the cumulative cross-sectional area increases, leading to a higher fill percentage. Careful planning and consideration of the number of cables are necessary to avoid exceeding the allowable fill limits. Fourthly, fill percentage limits. The NEC specifies the maximum allowable fill percentages for different types of conduits and cable configurations. These limits are designed to ensure adequate heat dissipation and prevent damage to cables. Adhering to these limits is essential for compliance and safety. Fifthly, cable type. Different types of cables have varying outer diameters and insulation properties. Communication cables, such as Category 5, typically have smaller diameters compared to power cables. However, it is still important to consider the specific characteristics of each cable type when calculating conduit fill. Calculating cross-sectional area. Accurately determining the cross-sectional area of cables and conduits is fundamental to calculating conduit fill. The cross-sectional area represents the amount of space a cable or conduit occupies in a given plane. The formula for calculating the cross-sectional area of a circular cable or conduit is cross-sectional area equals pi times radius squared, where pi is approximately 3.14159 and radius is 1/2 of the diameter. For cables, the outer diameter is used to calculate the cross-sectional area. For conduits, the inner diameter is used. Using consistent units, such as inches or millimeters, is essential for accurate calculations. Tools and resources for conduit fill calculations. Several tools and resources are available to assist in calculating conduit fill, making the process more efficient and accurate. Firstly, conduit fill calculators. Online conduit fill calculators are readily available from various sources, including electrical supply companies and engineering websites. These calculators typically require inputting the cable outer diameter, conduit size, and number of cables. The calculator then provides the fill percentage and indicates whether the installation complies with NEC requirements. Secondly, NEC tables and guidelines. The NEC provides comprehensive tables and guidelines for conduit fill. These tables specify the maximum allowable fill percentages for different conduit types and cable configurations. Consulting the NEC tables is essential for ensuring compliance and safety. Thirdly, cable manufacturer specifications. Cable manufacturers provide detailed specifications for their products, including the outer diameter, insulation properties, and other relevant information. These specifications are crucial for accurate conduit fill calculations. Fourthly, software and apps. Several software programs and mobile apps are available to assist in conduit fill calculations. These tools often include features such as cable databases, conduit sizing recommendations, and automatic fill percentage calculations. Fifthly, engineering handbooks. Electrical engineering handbooks provide detailed information on conduit fill calculations, NEC requirements, and best practices for electrical installations. These handbooks are valuable resources for engineers, contractors, and installers. Best practices for ensuring proper conduit fill. To ensure proper conduit fill and compliance with NEC requirements, consider the following best practices. Firstly, accurate measurements. Obtain accurate measurements of cable outer diameters and conduit inner diameters. Using precise measurements is essential for accurate calculations. Secondly, use manufacturer's specifications. Refer to cable manufacturer's specifications for the correct outer diameters and other relevant information. These specifications are typically more accurate than generic data. Thirdly, choose appropriate conduit size. Select a conduit size that is appropriate for the number and size of cables being installed. Consider the need for future expansion when choosing conduit size. Fourthly, follow NEC guidelines. Adhere to the NEC guidelines for conduit fill percentages. These guidelines are designed to ensure safety and prevent damage to cables. Fifthly, use conduit fill calculators. Utilize conduit fill calculators to verify that the installation complies with NEC requirements. These calculators can help identify potential issues and ensure accurate calculations. Sixthly, consider cable pulling. When calculating conduit fill, consider the ease of pulling cables through the conduit. Overfilled conduits can make cable pulling difficult and increase the risk of damage to cables. Seventhly, account for bends and fittings. Account for the impact of bends and fittings on conduit fill. Bends and fittings can reduce the effective inner diameter of the conduit, increasing the fill percentage. Eighthly, use proper installation techniques. Use proper installation techniques to ensure that cables are evenly distributed within the conduit. Avoid twisting or bunching cables, as this can increase the fill percentage. Ninthly, inspect the installation. After completing the installation, inspect the conduit to ensure that it is not overfilled. Verify that the cables are properly installed and that the conduit is securely supported. 10thly, document the installation. Document the conduit fill calculations and installation details. This documentation can be useful for future reference and for verifying compliance with NEC requirements. Understanding conduit types and materials. When selecting conduit for electrical installations, it is essential to consider the different types and materials available. Each type of conduit has unique properties and is suitable for specific applications. Firstly, rigid metal conduit, or RMC. RMC is a heavy-duty steel conduit that provides excellent mechanical protection for conductors. It is typically used in exposed locations where physical damage is a concern. RMC is available in various sizes and finishes and can be threaded for secure connections. Secondly, intermediate metal conduit, or IMC. IMC is a lighter-weight steel conduit that offers similar protection to RMC but at a lower cost. It is often used in commercial and industrial applications where moderate physical protection is required. IMC is also available in various sizes and finishes and can be threaded for connections. Thirdly, electrical metallic tubing, or EMT. EMT is a thin-walled steel conduit that is commonly used in residential and commercial buildings. It is lightweight and easy to install, making it a popular choice for many applications. EMT is typically connected using fittings and is not threaded. Fourthly, flexible metal conduit, or FMC. FMC is a flexible steel conduit that is used in locations where flexibility is needed, such as connecting to motors or other moving equipment. It is available in various sizes and can be cut to length as needed. FMC provides good mechanical protection but is not suitable for wet locations unless specifically listed for that purpose. Fifthly, liquid-tight flexible metal conduit, or LFMC. LFMC is a flexible metal conduit that is covered with a liquid-tight jacket. It is used in wet locations or where protection from corrosive materials is required. LFMC is available in various sizes and can be cut to length as needed. Sixthly, rigid polyvinyl chloride, or PVC conduit. PVC conduit is a non-metallic conduit that is lightweight, corrosion-resistant, and easy to install. It is commonly used in underground applications and in locations where exposure to corrosive materials is a concern. PVC conduit is available in various sizes and can be cut to length as needed. When selecting conduit, it is important to consider the specific requirements of the installation, including the environment, the type of conductors being used, and the level of protection required. Consulting the NEC and other relevant standards is essential for ensuring proper conduit selection and installation. Cable management techniques. Effective cable management is essential for maintaining a neat, organized, and safe electrical installation. Proper cable management not only improves the appearance of the installation but also enhances its performance, reliability, and maintainability. Firstly, cable trays. Cable trays are horizontal supports that are used to route and support cables in commercial and industrial buildings. They are available in various sizes and materials and can be installed overhead or under the floor. Cable trays provide a convenient and organized way to manage large quantities of cables. Secondly, cable ladders. Cable ladders are similar to cable trays but have vertical side rails that provide additional support and protection for cables. They are often used in applications where cables need to be routed vertically or where there is a risk of physical damage. Thirdly, cable ties. Cable ties are used to bundle and secure cables together. They are available in various sizes and materials and can be used to organize cables in a variety of applications. Cable ties should be installed properly to avoid damaging the cables. Fourthly, cable clamps. Cable clamps are used to secure cables to walls, ceilings, or other surfaces. They are available in various sizes and materials and can be used to support cables in a variety of applications. Cable clamps should be installed properly to avoid damaging the cables. Fifthly, cable glands. Cable glands are used to seal cables as they enter enclosures or other equipment. They provide a watertight and dustproof seal, protecting the equipment from environmental factors. Cable glands are available in various sizes and materials and should be selected based on the specific requirements of the application. Sixthly, labeling. Labeling cables is essential for identifying and tracing them in complex electrical installations. Labels should be clear, durable, and easy to read. Proper labeling can save time and effort when troubleshooting or making changes to the installation. Seventhly, color coding. Color coding cables can help to identify different types of circuits or functions. The NEC provides guidelines for color coding electrical conductors, and these guidelines should be followed when installing cables. Eighthly, documentation. Maintaining accurate documentation of cable routes and connections is essential for managing complex electrical installations. Documentation should include cable schedules, wiring diagrams, and as-built drawings. When implementing cable management techniques, it is important to consider the specific requirements of the installation, including the type of cables being used, the environment, and the level of organization required. Consulting industry best practices and standards is essential for ensuring effective cable management. Safety considerations for conduit and cable installations. Safety should always be the top priority when working with conduit and cable installations. Electrical work can be hazardous, and it is essential to take precautions to protect oneself and others from injury. Firstly, lockout/tagout. Before working on any electrical circuit, it is essential to energize the circuit and implement lockout/tagout procedures. This involves disconnecting the power supply and placing a lock and tag on the disconnecting means to prevent accidental energization. Secondly, personal protective equipment, or PPE. Always wear appropriate personal protective equipment when working with electrical equipment. This may include safety glasses, gloves, and insulated tools. Thirdly, insulated tools. Use insulated tools when working on or near energized circuits. Insulated tools are designed to protect workers from electrical shock. Fourthly, ladder safety. Use caution when working on ladders. Ensure that the ladder is properly positioned and secured before climbing. Avoid overreaching or leaning while on a ladder. Fifthly, confined space entry. Follow proper confined space entry procedures when working in enclosed areas such as manholes or tunnels. This may involve testing the atmosphere for hazardous gases and providing ventilation. Sixthly, grounding. Ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow, reducing the risk of electrical shock. Seventhly, overhead power lines. Be aware of overhead power lines when working near them. Maintain a safe distance from power lines to avoid contact. Eighthly, underground utilities. Before digging underground, contact the local utility companies to locate and mark any underground utilities. This will help to prevent damage to utilities and avoid potential hazards. Ninthly, fire safety. Be aware of fire hazards when working with electrical equipment. Keep flammable materials away from electrical equipment and have a fire extinguisher readily available. Tenthly, first aid. Be familiar with basic first aid procedures and have a first aid kit readily available. In the event of an electrical shock or other injury, seek medical attention immediately. Following these safety precautions can help to prevent accidents and injuries when working with conduit and cable installations. Always prioritize safety and consult with qualified professionals when necessary. Common mistakes to avoid in conduit fill calculations and installations. Avoiding common mistakes in conduit fill calculations and installations is essential for ensuring compliance, safety, and the long-term performance of electrical systems. These mistakes can lead to overheating, insulation damage, difficulty in cable pulling, and code violations. Firstly, inaccurate measurements. One of the most common mistakes is using inaccurate measurements for cable outer diameters or conduit inner diameters. Always refer to the manufacturer's specifications for precise dimensions. Using calipers or other measuring tools can help ensure accuracy. Secondly, neglecting cable fill tables. The NEC provides detailed cable fill tables that specify the maximum allowable fill percentages for different conduit types and cable configurations. Neglecting these tables can lead to overfilled conduits and code violations. Always consult the appropriate NEC tables for guidance. Thirdly, ignoring conduit body fill. Conduit bodies, such as LB, LL, and LR fittings, also have fill limitations. Ignoring these limitations can result in overfilled conduit bodies, making it difficult to pull cables and potentially damaging the insulation. Fourthly, overlooking directing factors. When multiple current-carrying conductors are installed in a conduit, it may be necessary to apply directing factors to the conductor ampacity. Overlooking these directing factors can lead to overheating and premature failure of the conductors. Fifthly, improper conduit bending. Improper conduit bending can reduce the effective inner diameter of the conduit, increasing the fill percentage and making it difficult to pull cables. Use appropriate bending tools and techniques to ensure smooth, consistent bends. Sixthly, using incorrect conduit size. Selecting the incorrect conduit size can result in either overfilled or underfilled conduits. Overfilled conduits can be difficult to work with, while underfilled conduits may not provide adequate protection for the cables. Use conduit fill calculators or tables to determine the appropriate conduit size. Seventhly, failing to account for future expansion. It is important to consider the possibility of future expansion when designing conduit systems. Providing extra capacity in the conduits can make it easier to add new cables in the future without having to replace the entire system. Eighthly, neglecting cable pulling lubricants. Using cable pulling lubricants can significantly reduce the friction between cables and the conduit, making it easier to pull the cables and reducing the risk of damage. Always use appropriate lubricants for the type of cables being installed. Ninthly, improper support of conduits. Conduits must be properly supported to prevent sagging or damage. Use appropriate hangers, straps, or other support devices to secure the conduits to walls, ceilings, or other structures. Tenthly, ignoring local codes and regulations. In addition to the NEC, local codes and regulations may also apply to conduit fill calculations and installations. Be sure to comply with all applicable codes and regulations to ensure a safe and compliant installation. By avoiding these common mistakes, electrical professionals can ensure that conduit fill calculations and installations are performed correctly, resulting in safe, reliable, and code-compliant electrical systems.